In this video, we're going to talk about density and displacement. So when I talk about displacement, I want you guys to think about if I have, say, a glass of water, and then I take a rock and I put it in the water, think about what happens to the water. Okay, so that's displacement. Okay, or if you have a bathtub and somebody gets into the bathtub, and let's say the water was almost near the top, and then you step into the bathtub, what's going to happen with the water? Well, it gets displaced. And chances are, if it's too close to the top of the tub, then there's going to be water pouring out of the tub onto the floor. So that's displacement. Now with density, density is let's fix my pen here. A measure of how much matter, when I say matter, I'm just talking about the stuff that it's made of, is in a certain volume. For example, a cubic foot of gold is more dense than a cubic foot of wood. So if you think about a cubic foot of gold, that would be really, really heavy, but a cubic foot of wood probably wouldn't be that heavy. Okay, so we're talking about the amount of material in a certain volume of that material. And then to calculate density, density is calculated by taking the mass or the weight of the object divided by the volume that you have of it. Alright, most of the time I'll just write this as D is equal to M over V. Alright, and then just remember what those letters stand for. Alright, so that's our definition of density. Let's go ahead and let's look at this first example with displacement. This is a displacement example. So a stone is placed in a 2.5 centimeter diameter graduated cylinder, causing the water level in the cylinder to rise 4.9 centimeters. What is the volume of the stone? So if I have my cylinder here, okay, initially we're going to have some water level that's maybe there. Okay, and then when I take my rock and I put it in there, there's my rock, the water level is going to rise. So now once I put the rock in the water level is going to rise to there. And they tell me that the water level in the cylinder rises 4.9 centimeters. So this amount of water that's been displaced is the same as the volume of the rock. So amount of water displaced is the same as volume of rock. So this is a clever way to find the volume of an irregular object. We place it in some water and we can figure out the amount of water that's been displaced, and that's going to be the same as the volume of the object. So the volume of the stone, that's going to be the same as this blue volume of water that's been displaced, and I know that's going to be area of the base times the height. And since this is a cylinder, the base is going to be pi r squared. times the height. So I have pi times, since the diameter was 2.5, the radius is going to be 1.25 centimeters. Divide that into 1.25 squared. And then the amount of water displaced, that's 4.9 centimeters. And if we calculate that out, we will get 24.05 centimeters cubed. So this would be, so this is actually the volume of the stone. Okay. Alright, so if you have questions about anything in this video, make sure you get help, and we'll see you in the next one.